Hello everyone, in this video I'm going to teach on how to write an ionic equation. Which type of reaction usually requires students to write ionic equation? So this is on my opinion, my experience only. So my first point here, when you see a chemical equation which their reactants and products are not in aqueous form. So this part will be discussed more in the later part of the video. Only compounds in aqueous form can be broken down to its ion. Next, my last point, do not break the elements or compounds which are in solid, liquid or gas form. With the exception of halogens, sometimes halogen can appear in aqueous form. Reaction that often need students to write ionic equation. So first point is neutralization. Second point is precipitation. Third point is displacement of halogen. Fourth is displacement of metals, redox, and electrolysis, which will be discussed in the later topics next time. Neutralization. It is a reaction between an acid and alkali to form a salt and water. Example 1, we have here sodium hydroxide and hydrochloric acid to form sodium hydroxide and water. Before you write down the ionic equation, make sure the equation is balanced. Now it is the time to break the aqueous into their ion form. So what ions present in sodium hydroxide? Na plus and OH minus. Next, for HCl, the ions present are H plus and Cl minus. To form NaCl in aqueous, so you break the ions Na plus and Cl minus. Water is in liquid form, so do not break it down, so you still write H2O. Okay, next is to cancel out what ions are the same on the left and the right. So from here we see the Na plus is the same on left and right. Next is the Cl minus. Okay, now we have to write down the remaining. So left with OH minus plus H plus to form H2O. So this will be your ionic equation. Please write down the state symbol, aqueous to form liquid. Second example, we have potassium hydroxide and sulfuric acid to form potassium sulfate and water. Make sure the equation is balanced. Okay, my reminder, balance. Now it is the time to break the aqueous solution into their ions form. Okay, for this potassium hydroxide, we have 2 of this, so it means there's 2 K and 2 OH. Okay, so let's write down, there's 2 K plus ion and 2 OH minus ions. Okay, this coefficient is representing for this K and OH. Please remind you that the coefficient in front of the sulfuric acid is 1. So if we were to focus on the H, so 1 times 2 of this H is 2H plus. So there are 2 hydrogen ions in sulfuric acid. Next is the sulfate ions. Let's focus here. So there is actually 1 sulfate ion, so we write SO4 2 minus. Okay, there's 1, yeah, but we don't need to write 1 there, so let's make it invisible to form K2. So which means there's 2 K plus ions plus SO4 2 minus to form 2H2O. Liquid cannot be broken down. Let's start to cancel the same ions on the left and the right. So we have the potassium ion, we can cancel it. Next is the sulfate ion. So left with 2OH minus plus 2 H plus to form 2H2O. Since all the coefficients are 2, we can simplify it by just dividing with 2. So left with H minus plus H plus is forming water. So what can we conclude from these two neutralization equations? And here. So no matter what acid or what alkali you use, they'll end up the same ionic equation. OH minus plus H plus to form water. Don't forget your state symbol, aqueous liquid. Precipitation. It is a reaction between two soluble aqueous solutions that will form a precipitate solid deposit as one of their products. Example 1. Reaction between aqueous silver nitrate, forgive me my mistake here, typo error, and aqueous sodium chloride. So you have here silver nitrate and sodium chloride to form silver chloride and sodium nitrate. The equation is correct and balanced, yeah. Firstly, those solutions are in aqueous form. You have to break down into their ion form. Okay, so for silver nitrate, the ions present inside are Ag plus and NO3 minus. Sodium chloride, Na plus and Cl minus to form. Silver chloride is in solid, so you don't break them down, so still stays strong. Plus you have to break this sodium nitrate, Na plus and NO3 minus. Now you cancel the same ions on the left and the right side of the equation. Sodium nitrate. So left with Ag plus and Cl minus to form AgCl. Right, the state symbol is aqueous to form your solid. This is your famous white PPT when you see this in your qualitative experiment. Another precipitation reaction is this reaction between aqueous barium chloride and sulfuric acid. So here's the equation. Make sure the equation is balanced after you have written it down. Label who is the aqueous solution, who is the solid product. So as you know, this should be the precipitate BaSO4, BaSO4. So let's break down these aqueous into their ionic form. Barium chloride, Ba2 plus. But since this chloride has 2, so you put plus 2 of the chloride ion, because as you know, chloride is charged with a -1. So with this 2, you must put 2 here in front as a coefficient. Okay. Plus the sulfuric acid, this one, as you know, hydrogen ion present as H plus. So when you have these 2, so you put 2 as a coefficient in front of the H plus SO4 2 minus to form BaSO4. Still stays the same because it's a solid, plus 2 of the hydrochloric acid as a product. So 2H plus, and don't forget, since this chloride, although it's 1, but there's 2 in front of this product, so don't forget to expand, just like maths. 2Cl minus. Okay, now you have to cancel the same ion between left and right side. So let's see your chloride and your chloride, your hydrogen ion and hydrogen ion, no more. So let's write the remainder, Ba2 plus SO4 2 minus to form BaSO4. Put the state symbol, this is from the aqueous, lastly product. Okay. Third example, you have aqueous ion 2 sulfate and aqueous sodium hydroxide. So actually this is the test for cation, if you notice. So this is the green PPT, the dirty green PPT. So let's write down the ionic equation. So firstly we have to break the aqueous into the ionic form. So let's break the FeSO4. So the ions present inside FeSO4 are Fe2 plus, because here is 2, plus SO4 2 minus. Okay, next there's 2 of Na and OH, so 2 Na plus 2 OH minus to form. Since this FeOH2 is a solid, so this one still stays the same, FeOH bracket 2 plus, you break this Na2 SO4, so there's 2 Na, so I'm gonna write 2 Na plus SO4 2 minus. Alright, so now let's cancel the same ion on the left and the right, sulfate and sulfate, sodium and sodium. Alright, let's write the remainder, Fe2 plus 2 OH minus to form Fe bracket OH2. Okay, so what can you conclude from writing the ionic equation for this precipitation reaction? So when you know that particular product is the precipitate, especially this AgCl, when the question asking you to write the ionic equation for this precipitation reaction, then you know the product is this silver chloride. So what I would always do is just to write the product first on the right hand side, then followed by the arrow, and you know the left hand side should be the ions that's forming the precipitate, which is the Ag. Silver is Ag plus and chloride is Cl minus. So just put the state symbol Aq and Aq, and this is the solid. Same goes with this example, example 2. If you know these two aqueous solution that will produce you barium sulfate, which is the precipitate, if the question asking you to write down the ionic equation for this reaction, first thing I'll do is, I know the product is barium sulfate, so I'll just write barium sulfate first, then followed by the arrow, then identify the ions. Ions for barium is Ba2 plus ion for sulfate is SO4 2 minus. Aqueous solid. Same goes with this. You know this is the precipitate, the dirty green precipitate, so you just do the reverse engineer. Ion for ion 2 is Fe2 plus, and you need 2 of the hydroxide ion because there's 2 for this hydroxide, so 2 OH. In this video, I am going to discuss on how do you write the ionic equation for displacement of halogen. So firstly, you must know what is displacement of halogens. If a stronger halogen is added to a compound containing a weaker halogen, it will react with the compound to form new product. In other words, a more reactive halogen will displace a less reactive halogen from its halide solution. So what did I mean by a halide solution? The word I, it means the ion form of halogen. You know halogen, they present as F2Cl2 Br2 I2 S2. This is the diatomic form. So if you remember the IED, this is when your fluorine, for example fluorine, will form fluoride. So you have those chloride, you have bromide. The IED is the compound form, such as sodium chloride. This is the compound, right, which you often see as NaCl. That's what I mean by halide solution. Alright, this is a halide containing solution, which is the sodium hydroxide. This is just an example, yeah. So I'm gonna erase this. Okay. So as you can see from the chart, fluorine is the strongest, then the weakest should be astatine. Here I have one example. Fluorine react with sodium chloride to form sodium fluoride and chlorine. So what means that this fluorine managed to kick the chloride out of sodium chloride. Then this fluorine will overtake the position to become sodium fluoride and chlorine. Just to brief you, fluorine is on the top, chlorine is below of fluorine, so this will overtake the position of chlorine. Yeah, just remember, the strongest will dominate the world. Let's start to write the diatomic form. Just a reminder, for halogens, most of them appear as aqueous form in diatomic. Please do not break the F2Cl2 Br2 I2 or S2. Okay, so let's start to write the ionic equation. Fluorine F2 plus, this is the aqueous of sodium hydroxide, sodium chloride, so you break them to ionic form, 2Na plus and 2Cl minus to form 2Na plus and 2 fluoride plus chlorine. So now we remove which ion is the same on the left and the right, sodium and sodium. So left with F2 plus 2Cl minus to form 2F minus and Cl2. So this will be your ionic equation for this displacement of halogen. Example 2, you have chlorine react with potassium iodide to form potassium chloride and iodine. Okay, so how this reaction happen? You have chlorine on the top, next followed by bromine, next followed by iodine. Just follow the periodic table. So as you go down the group, the reactivity decreases. So if you can see, chlorine should be stronger than iodine. So this chlorine should overtake the position of iodide here, should kick this out. So this chlorine chloride will take over to stay with this potassium. So let's start. Chlorine Cl2, do not break them. So break this aqueous potassium iodide, 2K plus plus 2I minus to form 2K plus plus 2Cl minus plus I2. So let's cancel the same ion on the left and the right, which is potassium. So left with Cl2 plus 2I minus to form 2Cl minus plus I2. So this will be the ionic equation.